Hello, I'm Channa Bankapur. I'm going to discuss my solution to the LeetCode problem, Decode String. It's today's daily challenge in LeetCode. So the problem definition is we have an encoded string and we need to decode it. And the output is going to be a string. So let's understand the encoding and then how does the decoded string looks like through a few examples. So here in the first example, the encoded string looks like this, where 3 is followed by a in square brackets and 2 is followed by bc in square brackets. What does essentially it mean is in the decoded string, a should appear 3 times. Three indicates the repeat count, and bc as a substring appears 2 times, right? So bc followed by bc. And similarly, in the second example illustrates the nesting of these kind of encodings. If you look at inside here, C should appear twice, which is preceded by A, so it's going to be ACC. And now ACC has a whole substring is going to be repeated 3 times because 3 appears outside of that. And so these can be one after the other also concatenated. Suppose ABC appears twice, followed by CD appears 3 times, and then followed by some EF which is not even encoded, right? So these examples should be clear enough to understand what the problem is. Now let's try to I'll come up with a little more elaborative example so that I can come up with an approach. Suppose the input might look like, so it has say AB followed by say 2 times of CD, and then 3 times of EF, and then followed by 2 times of GH, and then this closes the 2 times repeating, and followed by maybe IJ which is not encoded at all, and then again 2 times of say KL. It's a long encoded string. So how does the decoded string is going to look like? So AB is going to be there as it is. And now let's try to decode these things. So CD is going to appear twice, but yeah, CD followed by EF is going to appear, 3 times. So EF, and then EF, followed by twice GF. So which is going to be, sorry, GH, and this whole thing starting from CD, it's going to appear one more time because we need to repeat twice. CD, EF, then GH, and followed by IJ, which is not encoded, and KL is going to repeat twice, KL and then KL, right? So how do we generate such a thing? Now, if you look at here, these square brackets indicate something. Whatever is inside is going to be repeated by the number which is preceded by that square brackets, and this can be nested. That means the encoding, whatever the encoding that started recently is going to end first. That's how these nested parentheses or nested brackets are going to look like, right? So that gave me an idea of stack. So maybe stack is going to help us in decoding this. So what I'm going to do is I'll start with the, so stack kind of remembers whenever I have something like open bracket here, I'm going to push something into stack, and then when it closes, then I'm going to pop it out and do whatever it needs to be done. That means whatever the number of times it needs to be repeated, I'm going to repeat that. Until then I can keep continuing as whatever the string is going to give me. So this is how I'm approaching. So my approach is going to be, I'll keep processing one character after the other. So if I get just an alphabet, I'm just going to keep appending it to the result. So for me, the result string is going to look like this. So to start with, I have A, so A is going to appear as it is. And then when I get B, B is also as it is. Now I got a digit, so digit is not going to be part of the output, but I need to do something. So digit indicates there is something that's going to be repeating. That means the open bracket is going to appear. So now I'll read the digit first, or digit or a sequence of digits, which is just an integer. So that is going to be the repeat count. So now I know the repeat count as 2. Uh, and whatever that appears from this point onwards in the result string until the corresponding closing bracket is going to be repeated so many times. So this is what I want to remember. So in my stack, I'll remember this as this is the point I'm going to insert, or this is the point which is going to be repeated. The start of the substring which is going to be repeated, which is say the index is 2 here, right? So if I say 0, 1, this is going to be index 2. So index 2, but along with that, I need to know what is the repeat count. In this case, repeat count is also 2. So this is like a pair. I'm going to push it into my stack, right? So let's call this as something like in a k stack. So this is going to have 2 comma 2. So the first two indicates the index of the resulting string where the substring begins, which needs to be repeated. I don't know the length of that, because when I get the closing brackets, closing corresponding closing bracket, then I'll know the length. But now I know the repeat count at least, so I'm going to have these two things. Now, after this, the index, or the we are going to process C starting from C. So C is just a character. I'm going to put C here. So I'm not doing anything for this one. The result string is has C here, but look at this. This kind of point is the first stack push, right? Which is more like 2 comma 2, right? And now I get a D in the input, and then I'm going to say D here. Now we got another digit, so which needs another push, right? So that push is going to be, so the index here is going to be what, 4 4 comma whatever the count it says, repeat count is 3. So 4 comma 3 is my next item to be pushed into the stack. So then I'll start processing E, and then F. Now I have a closing bracket. So the closing bracket indicates whatever recently I pushed is going to be effective now. So what does the recent one says? The recent one is 4 comma 3. So this I'm going to pop out. So 4 comma 3 is out of the stack. What does 4 indicate? It is the beginning of the substring that needs to be repeated. That's starting from E in my result string. And 3 is the repeat count. So until the current one. So until the current one, if I know what is the size of my result, which is 6, 6 minus 4 is going to be 2. So 2 is the size of the substring that's going to be repeated. So I'll take this size substring of length 2 starting from 4. So if you have some kind of function which is like substring of say result, so result dot substring of starting from index 4 in this case, of length 2. So this is the substring that I'm going to take out, and then I keep this needs to be repeated twice, the number of times, right? Whatever the number of times it says, which is 3 in this case, 3 times. But one time it already appears, so I need to append 2 more times. So that's why I'm going to append EF followed by EF, right? So that's how I went to this point now. So what is the index? We have 4, 5, 6, 7, 8, 9 are done. So 10th index is what we are at right now, right? So now after this closing parenthesis, closing bracket is done, we got another 2 here, 2 open bracket then GH, right? So that 2 is going to be another push. So this is the another push point, which is going to be index 10 comma 2, repeat count 2. So in my stack, this is going to be 10 comma 2. So 10 is the index at which the substring starts, and 2 is the repeat count, right? And now I got G and followed by H, and now the closing bracket is there, the first closing bracket, which indicates I'm going to pop out this 10 comma 2. 10 comma 2 indicates starting from 10, whatever up to the current length, which is current size is already 12, right? So 12 minus 10 is 2. So a substring of length 2 needs to be repeated twice. One time it already appears, so one more time you're going to append here. So GH. So now we have something up to this point, and now another closing bracket is seen in the input. So that means we are going to pop out another one, 2 comma 2 from the stack. So 2 comma 2 indicates starting from index 2 in the in the result string, whatever up to the length. The current length is 14, so 14 minus 2 is going to be 12. So a substring of length 12 needs to be repeated twice. This second 2 indicates it should be repeated twice. One time it already appears, so I just have to repeat one more, append one more time. So I'll extract a substring. So result dot substring starting from say index 2 of length 12. I need to extract it and then append once more here. So that is going to be um, so it starts from C, right? C, D, E, F, E, F, E, F, G, H, G, H, right? After that I get I, and then I j. So those appear as it is, and then I get another digit. So stack is empty now. So that means I got like one more entry in the stack. That is the only entry we have, and the index of that is whatever the index here, right? And so that, let's say it is I, and then starting from that, the repeat count should be 2. So now I get K and then L, and after that there is a closing parenthesis. Closing parenthesis tells us we are going to pop it from the stack, and that gives me the length. So the current length minus I is going to be 2. That repeats twice. One time it is already there, so I'm going to have one more KL, right? So after that my input string is done, and I have a result string also, right? So this is the idea I'm using. So stack is obviously a natural data structure for a problem like this. But in addition to that, I'm already process. So whenever I'm parsing the input string, I'm not going back anytime except for the repetition of that where I need to extract the substring. So otherwise, this pretty much works in the in the linear time complexity of the resulting strings length, right? Let me illustrate that with my code, and that should be clear. So this is one of the fastest way of implementing, right? Let me show my code. So here I have this stack where the data type of that stack is going to be a pair of int comma int, where the first parameter is going to be um, the starting index of the substring in the result, and the second value is going to be repeat count. So result substring needs to be constructed, so that starts with empty, and I is going to be the index of the input string, right? And we need to keep processing it. So these are only the three possible cases I come across. If it is an alphabet, that means if it is alphabet, then I just append it to my result string, right? That's all I need to do. If it is a digit, so digit is always followed by, or a series of digits, a sequence of digits is going to be followed by open bracket. So this is essentially a case where we need to push into the stack. So because I start with the digit, and then these 3 4 lines are going to get that number, get that count. If it has more than one digit, it's this is how I'm going to get it. And that count along with the current index of the result string, because whatever we have, the substring we are going to repeat is going to start from now onwards, right? That means it is it's at the end of the current result string. So that's why result dot size is going to be appropriate. So only other case is the pop case, where when we get the closing bracket, we need to pop from the stack and then take appropriate action. So when we take it out, we know that the starting index in the substring in the result string is going to be the first first value in that pair, and the second value is going to be repeat count, right? So length of the substring we need to extract is going to be known now, which is whatever the end of the result right now minus the start index is going to be the length of the substring we need to extract. So that substring I extract here, and I keep appending it to the result, the count minus one number of times, because there is already one time which is present. I just have to append another count minus one number of times. So this while loop is going to do that. So in any case, I'm going to increment I here, but I can also be incremented in this inner while loop, where we are actually processing each digit. So, but otherwise, I is kind of incrementing sequentially. All right. So let me submit the solution and show how does it look like. So yeah, it accepts. And the time complexity here is linear to the resulting result string. Why do I say that is? So the input string, the order of result string is always greater than or equal to the order of input string, because the output string, the only thing that is extra in input string is those brackets and the numbers, or the repeat counts, right? So those are not an extra order of magnitude. But what if the repeat counts are much bigger? So in that case, the result string is going to be much longer. So that's why, and if you see here, everything. So this while loop is actually is going to run for the number of times of the input string length. But there is a while loop here again, but here I is incrementing every time. So this is still part of my input strings, parsing. But the case where we take extra time is in this while loop. So this while loop is mainly for the repeat count, right? And we take a substring and then append it, so it's not like a constant time operation. We need to get that substring, and when we append it, it's going to take linear time to that length of the substring we're appending it. So that is a so this whole thing now adds up to the length of the output string or the result string. So that's why we can say that the big O of maybe length of the output string, right? So that's basically the time complexity here. Or generally we just say big O of n because this is a linear time taking algorithm. All right. So if you have any other way of approaching this problem, and yeah, and if you have any questions on this approach, please comment below. Otherwise, please like the video and subscribe to the channel. And thanks for watching.